What's up, you freaking geniuses? So in this video, I'm going to teach you how to graph sine and cosine functions with transformations. And I'm also going to teach you how to find the domain and range. So here are the two parent functions. These are the graphs that we actually transform. So here on the left, we have the parent function of sine, right? Y is equal to sine of x. And here we have y is equal to the cosine of x. So starting with y is equal to the sine of x. One key thing I want to point out is that it always starts right here at the origin, right? You could think of that as the origin or at 0. And the way I remind myself that sine is the one that starts at 0, it kind of sounds the same, right? Sine 0, sine 0. So sine starts at 0, and on the other hand, cosine starts at positive 1, right? The parent functions. Now, the key points along this x-axis are pi over 2, pi, 3 pi over 2, and 2 pi. So you can see that the length over here that we show goes from 0 to 2 pi, right? So this whole length right here is called the period. So this graph actually just keeps going on forever, but when we graph these, we just show one full period, right? Now, this is the equation that we're going to use down here. So it's just y is equal to a times the sine of bx minus c in parentheses plus d. Now, a over here stands for the amplitude, all right? A is the amplitude, and the way that you find it is you just take the absolute value of this number right here, and that's the amplitude. Now, on a graph, the amplitude is this distance right here. It's basically from your x-axis, or a little more specifically, from the center of the graph to the top or down to the bottom. So on the parent function, you can see that the highest point we hit is a positive 1, and the lowest point we hit is a negative 1. So the amplitude for the parent function would just be equal to 1. Okay, then we have the sine or cosine of, again, bx minus c. B is going to help us find the period. So as I explained already, the period is just the full length that we graph, right? One full cycle. And that, the way you find that length is going to be equal to 2 pi over b, the absolute value of b. So the absolute value of whatever number is right there. And then we have c, which stands for the horizontal shift, also known as the phase shift. And lastly, we have d, which is the vertical shift, right? Up or down. Okay, this time we have y is equal to 3 sine of 6x plus pi. So again, let's identify our variables here. So this is a, this is going to be b, and this is going to be c. And we don't have a d either, okay? So again, a is going to be the amplitude, right? B, or this number next to the x variable is going to be our b, and then this is our c, which again just shifts our graph left and right. So let's just go through finding a, b, and c. So a is the amplitude. So that's going to be equal to the absolute value of a, which in this case is 3. So the amplitude in this case is going to be 3. And then we're going to use b to find the period, right? So the period is going to be 2 pi over the absolute value of b, which in this case is positive 6. So this is equal to 2 pi over 6, and 2 over 6 reduces down to 1 over 3, right? 1 over 3. So this is equal to 1 pi, or simply pi, over 3. All right, and we do have a horizontal shift, right? A phase shift, denoted by this variable c. Now, the way that you find the left and right ends of the shift are using these two formulas right here. So the left end, let's just write it over here. This is going to be the left end, the first equation, and this is going to be the right end. All right, so the left end, let's find the left end first. So that's going to be equal to bx minus c, essentially what's inside of the parentheses, right? Bx minus c, and you're just going to set that equal to 0. So inside of these parentheses, we have 6x plus pi, so we're simply going to set that equal to 0. And all we have to do is solve for x. So here we can subtract pi from both sides, right? So then we're left with 6x is equal to negative pi. And then to get rid of the 6, we'll divide both sides by 6, right? Those cancel out. So we're left with x is equal to negative pi over 6. Or we can write that as negative pi over 6 like that, all right? So this is the left end. So we'll move that up there. And now we will find the right end. So for that one, we are going to, again, just take what's inside of our parentheses and set it equal to 2 pi this time. So in this case, we're going to have 6x plus pi is equal to 2 pi. All right, so again, we're just solving for x. So here we can subtract pi from both sides, right? Essentially 1 pi. So those cancel out, and we're left with 6x is equal to 2 pi minus 1 pi is equal to 1 pi, or simply pi. And then again, to solve for x, we'll divide both sides by 6. Those cancel out, so we get x is equal to positive pi over 6. Okay, so now if we draw our graph, we're going to have a left side and a right side, okay, because as you can see, we're going to go into the negative side over here, and we're going to have the right end over here in the positive side, okay? So the amplitude, again, is positive 3, so that means, let's extend this maybe just a little bit more. The top is going to be at positive 3, and the bottom is going to be at negative 3. Okay, and we also know that the left end is at negative pi over 6, and the right end is at positive pi over 6. So they're both the same distance away from 0, right? So if this is 0 right here, the left end is, let's just say over here, negative pi over 6, and the right end, we'll just say it's about there, right? Positive pi over 6. Now the period tells us that the whole distance from the left end to the right end should be pi over 3. All right, so we're saying that this distance right here, the period, is equal to pi over 3. And we can confirm that, right? Because this distance right here is pi over 6. And this distance is the same, right? Pi over 6. So what's pi over 6 plus pi over 6, right? Pi over 6 plus pi over 6 is equal to 2 pi over 6, which reduces down to, right, 2 over 6, 1 over 3, so that reduces down to pi over 3 also, all right? So that looks correct. So the last thing that we have to do is simply find this point and this point. Why is that? Well, remember, we have to split the whole period into 4 even pieces, right? This is 1, 2, 3, 4. So to make this easy, what's halfway between 0 and pi over 6? Well, if we know this whole distance is pi over 6, and we want to know what half of that is, let's just multiply by 1/2. Well, that's equal to pi over 12, all right? So this distance, or this point right here, is pi over 12. So that means this point right here must be negative pi over 12. All right, so now that we have this split up into 4 even pieces, now we can graph our sine function, all right? So again, starting over here at the left side, it's almost like our origin has moved, right? So instead of starting over here, we're gonna start over here, right? This is the left end now. And then we're gonna go up to positive 3 right here at negative pi over 12. Then we're gonna come down to the x-axis, come down back there, and then we're going to go over to pi over 12, and then we're gonna go down to negative 3 this time, and then come back to pi over 6 at the very end, all right? So then we're just going to connect the dots like that, all right? Lastly, let's find the domain and range. So the domain, again, for all of these, are always gonna be the exact same. It's gonna be all real numbers, or again, we could write that as negative infinity to positive infinity, whatever floats your boat. And then the range is just the vertical limits. So here it's gonna be from negative 3 to positive 3, right? So from negative 3 to positive 3. All right, lastly, let's do this big ugly one right here. So we have y is equal to 4 cosine of pi x plus pi over 2 in parentheses minus 1. So again, let's just identify our a, b, c, and d, right? So this is our a, this is b, this is c, and this is d. All right, so that means starting with a, right, the amplitude is going to be equal to the absolute value of this number right here, which is going to be equal to simply 4. And then we're going to use b to find the period, right? So we're going to say that the period is equal to 2 pi over the absolute value of b, and in this case, b is pi, all right? So the absolute value of pi is simply pi. So then here we can cancel those pi's out, and we're simply left with 2. Okay, C tells us, since we do have a number here for C, that tells us we're going to have a horizontal shift or phase shift, right? So we're going to use our 2 formulas right here. So again, to find the left, it's the top one, and to find the right end, it's this bottom one, right? So you're just going to take whatever's inside of your parentheses. So in this case, pi x plus pi over 2. And we're going to set that equal to 0 to find the left side. So again, solving for x here, we can first subtract this pi over 2, right? Subtract pi over 2 from both sides. These cancel out. We're left with pi x is equal to negative pi over 2. Okay, now to isolate this x, we need to get rid of this pi, so we can either divide by pi, or what I would suggest in this case is multiply by 1 over pi. And again, what we do to one side, we do to the other. So we're going to multiply this side by 1 over pi also. Okay, and the reason I recommend multiplying by 1 over pi instead of just dividing by pi is because it's a little bit easier to just multiply fractions straight across, right? So in any case, on this side, this 1 over pi and this pi, those cancel out. So we're left with x is equal to, and then over here, before multiplying straight across, you can see we have a pi on top and the bottom, so we can cancel those out. So now all we're left with is a 1 on top and a 2 on the bottom. And it's negative, right? So that means this is negative. So we get that x is equal to negative 1/2, right? So this is the left limit. And to find the right limit of the graph, now we're going to take this in parentheses, let's see, plus pi over 2, and set this equal to 2 pi this time. And again, we're solving for x. So here, again, we'll subtract both sides by pi over 2, right? Subtract pi over 2, those cancel out. So we get that pi over x is equal to 2 pi minus pi over 2. We can rewrite this as an equivalent fraction. It has to have a denominator of 2. So we can multiply the top and bottom by 2. So right now it's basically 2 pi over 1. And if we multiply the top and bottom by 2, we'll get 4 pi over 2. And again, that's minus pi over 2, which is equal to 3 pi over 2, all right? So this is equal to, again, positive 3 pi over 2. Now to solve for x, again, we can just multiply both sides by 1 over pi, right? Multiply by 1 over pi. Over here, these cancel out, so we're left with x is equal to, canceling these out one more time, 3 times 1 on top and 2 on the bottom. All right, so this is the right side, right? X is equal to positive 3/2. Okay, and then lastly, this time we finally do have a number right here at the end, this D number, which is -1. So that means we're going to shift this whole graph down 1 unit. All right, so now that we have all our information, now let's graph this. So we're going to have stuff on the left and the right, negative side and positive side, right? Because our left end is -1/2. So let's graph this -1/2. Let's just put it there. And then the right end is going to be at positive 3/2. Okay, then our period is 2. So the distance from the left end to the right end, that whole distance should be equal to 2. And it is, right? Because 3.5, that's the same thing as basically 1.5. And then this is the same thing as 0.5. Okay, now again, we just have to split our whole period here into 4 even pieces. And the way that we can do that is take your period, 2, and simply divide it by 4, right? Because we want 4 even pieces. So 2 divided by 4 is equal to 1/2, right? So this is already a distance of 1/2, right? So this is basically 0 right there. So this distance from there to there is 1/2. So then we'll also do the same thing in this direction, right? So we'll say that this is approximately 1/2, and then we'll go another half. So 1/2 plus 1/2 is equal to 1. And then 1 plus 1/2 is equal to 3/2, right? Or 1.5. And then lastly, we need our amplitude, right? So our amplitude is 4. So we could say that this is 4 right here, and this is -4 right here. However, don't forget, we have to shift this graph down by 1. Okay, so we're not going to get all the way up to 4. We're actually only going to get all the way up to 3. And then down here, we're actually going to go further than -4, right? We're going to go 1 down past that, down to -5. All right, so we're not going to use U, and we're not going to use U. Okay, that also means that our x-axis shifted down essentially 1 spot. So this is basically -1 right here, right? So we can say that this is -1. Okay, so now if we graph this cosine function, the left end is over here at -1/2, and we're gonna go at 3. That's as high as we're gonna go, at +3. And then the next critical point is right here at 0. But again, we're not gonna use this original x-axis. We're gonna go down one more space right here to -1, right? Because the distance from 3 to -1, that distance is 4, right? That's the amplitude. What's the distance from -1 to -5? Well, that's also 4, right? The amplitude. Okay, so again, that's why that point goes there, and then we'll go to 1/2, and then we'll go all the way down to -5, and then we're gonna come back up to -1 at 1 right there, and then lastly, we'll go up to +3 and at 3/2 right there. So our cosine function is gonna look something like that, all right? Lastly, the domain and range. So the domain, again, is just gonna be all real numbers. And the range in this case, the lowest part is -5 and the highest is +3. So -5 to 3, boom. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.